Hello then, welcome to this Pandas challenge, day 23 of 30. My name is Valentine and I'll be your instructor. In this challenge, we'll be going through another set of Pandas concepts that will be important in data analysis work. So let's get started. The first thing that you need to do is visit the description section of this link and then click on the practice resource link. That should take you to the page that you see on your screen. Then click on the sample practice resource link. That should take you to the notebook that we're going to be using for this workshop or for this video. So feel free, by the way, to pause the video and get to this particular point. Right, once you get here, you need to go to File, then Save a Copy to save a copy of this notebook so that you can be able to refer to it with the changes that you've made in the future. I'll be using the practice notebook. This is available to Afterwork members, and they get a whole lot of more content, and you can always become an Afterwork member if you're interested in that. So once you get here, once you get to the sample practice notebook, which is actually simple to the practice, it's similar to the practice notebook. And once you have saved a copy, use that copy to now work through or to go through the learning experience. Okay, so the first thing that we need to do is to run the prerequisite code cell. This should import the Pandas library that we are going to be using for data manipulation tasks. Initially, when you're running this, it should take a few seconds, maybe 10 to 15, because what happens is that your notebook is connected to Google servers, which run the code that we're going to be running. Okay, so starting off the first concept, reordering columns in a data frame. So assuming that we had this data frame that contains information about materials for construction, we can reorder the columns in an order that in a format or an order that makes sense for us. So for instance, if we wanted to have, say, material ID, material name, then category, supplier, unit price, location, like if you wanted to reorder, we can first of all use this approach. We can first of all create a Python list with the order that we want, and then we can then decide to pass that list to the reindex column, reindex function, and we set that list as the value for the columns parameter. So if assuming I had this and I wanted to switch maybe something like category with material name, I could simply just swap them. Let me paste this here. And if I run this, I should be able to see that after material ID, I have category. So generally what's happening is just some reordering that happens. So yeah, so that's what we've got for the data frame that we have. It's in a shape that, or it's in the order that of columns that we would want. All right, pause the video and then work on the challenge. Moving on, we can decide to work with text data using string methods. So if assuming we had this other data set that still contains construction materials records, so if we had this data set and we wanted maybe to convert maybe a certain column such as material name to a certain case that makes sense for us, then we can do we can use string methods such as upper. We can also extract strings, maybe extract the first word from the description column that we have on the far right, say high quality, Portland, and store it maybe in a new column. We can do the same thing. So here we're going to just uppercase the values for the material name column as well as for first word description. So for this particular description column, we're going to extract the first word for the text that's contained or the value that's contained in that column and store it in a new column called first word description. And here we're just displaying the columns themselves, the new columns that we've created. All right, pause the video and then work on the challenge. In some situation, we might want to search for text inside columns or retrieve records that contain certain text in the columns that we are interested in. So for example, if we had this particular if we had this particular data set again that contains construction materials, we might want to retrieve records that contain the word concrete, so keyword concrete, inside the material name column. So inside this column, we might want to retrieve now we might want to retrieve the records that contain the word concrete. So how we do that is just we can define the keyword that we want inside a keyword function, inside a keyword variable, then pass that variable to the contains function, and that we apply to the column that we want. And we use just Boolean indexing approach to get the record that we want. And we display the filter data afterwards. Right, pause the video and then work on the challenge. In certain cases, we might want to retrieve records that are within certain date ranges. So if we had this other data set that contains information again about materials, and it contains some columns about order date, delivery date, start date, and end date, we might want to maybe filter this data set based on maybe a specific time frame, maybe between could be between some of the dates that we have here. So first of all, what we need to do is to convert those dates, those columns to have a date time format. Then once we have done that, we can perform our filtering process, and we use just the Boolean indexing approach, where we set our conditions. We have two conditions here, so we can close them in parentheses, and we we say that we want to check for both using the and or ampersand sign. So we say df order date is greater than or equal to start date. So we want to filter records that have order date greater than or equal to start date, and also order date less than end date, which we have defined here. End date is just the variable that we have here as well. And that should give us the filtered records, which you see here. Right, pause the video and then work on the challenge. In some cases, we might want to just select data in a data frame by its data type. So we might want to retrieve maybe all the numerical variables, or all the categorical variables, or all the object variables which contain text. So assuming that we had this data set that contains columns that have these data types, so integers, object, float, we could decide to select those columns using the select types dtypes function, and we apply that to the original data frame. But inside that function, we set now the data types that we want, and we set them inside a Python list, and for each and every element in that Python list, it would represent an object type. So it would represent a data type, so int 64, etc. So here we want to retrieve these two the records with these two data types as shown here. Then we display the selected numerical columns. All right, for categorical columns, we just use object. So well, not really categorical. Well, you could still have categorical data type. Here it's just textual, not necessarily categorical, but it gets the data types with the object. But we could still convert some of these ones to have categorical format. Sometimes if you wanted categorical, it would be categorical, just like that. I think this has been it's different, but yeah, that's just about it with regards to that. Pause the video and then work on the challenge. In some cases, we might want to filter for data not using Boolean indexing. We might want to use a query method and then check for for either of the conditions that we want. So if we had again this data set that contains, but now this one contains just information about projects, construction projects. If we wanted to get records that are greater than 10,000, not 10,000, greater than a million, that have a budget greater than 1 million, and status is in progress, then we can decide to use the query method, and inside it set the conditions and separate them by the OR operator, which is just a pipe, to just mean that we want to check both conditions, and or not both either. So if records have this condition turning out to be true, or this condition turning out to be true, just note that or, and then we will be displaying that. All right, pause the video and then work on the challenge. In some certain cases, we might want to add ranks. So we might want to calculate for ranks within groups. So assuming that we had a summary table that we created out of a larger table. So assuming that this is our larger table that we have here that contains materials, construction materials records, and we wanted to create a summary table. We could say, let's say, category versus total cost, which would be the sum of the total cost. So assuming we created that, and we also aside from that, we also wanted to rank now the records based on the rank of the category as per the total cost. Then we can do as such. So we can decide to specify that we want to calculate ranks within groups based on, say, in our case here, category and total cost. So we group by the total category, and then we would want to get the total cost. I think here we should add an aggregate function such as sum. We could also do that. But again, if we do this, we create a new column called rank and apply the integer data type to the rank column and store those values of that rank column as a new column. So, and we can be able to display them as such. So for example, we could see bricks itself has actually belongs to category 2, which is masonry. We could also do the same thing. You can see concrete also belongs to not category 2. It belongs to it's ranked second based on the category that it has been categorized as. All right, pause the video and then work on the challenge. And moving on, when it comes to accessing data from columns, we can use what is called the bracket notation or the dot notation. So this is something that we might have been doing, but not that consciously. So if we wanted to get the records, the values for this particular column, say material name, we use df, then square brackets, that's a bracket notation, and the name of the column, and we store the values in materials bracket. So this essentially just gets the data that we have for that column. If we want a data frame format, you can always just use double square bracket, or you could also use I think reset index, but just double square bracket should work. If you wanted, again, and you can see here we have both, we have two words. If just we had one word, we could just have used maybe df dot then the name of the column. But here, because we only have one word, this still works well. It's usually called the dot notation, so we could have said df dot then material name, but because it's a double, the two words, then we can't use that in this situation. So this also gives us information about now the actual whatever that we have generally in terms of the data that we're working with for the respective column. And again, if we wanted to modify that data in that column, again, we'll just use the bracket notation. Could still use the again dot notation if we had just one word in that column name. But here we just use the bracket notation, and we use an apply function to apply some sort of function. This is just a lambda function. And yeah, so we just replace the original values, and this is what we've got. Pause the video and then work on the challenge. In some other cases, when we are working with time series data, so data that contains some time component, such as the one that we're going to see here. So assuming that we had this particular data set that contains date information, we could create a time series plot or plot that gives us information generally about trends, or how those values or how other numerical values change with respect to time. So assuming this is the data set that we have and we want to work with the date column, we would first of all need to convert it to a date time format, then use the plot function and set the kind parameter to line, to have the value line, so to specify that we want to create a line plot, which is just generally a line, a time series plot. And we set the x-axis to date and y-axis to price. That's the variable that we want to check for, or to understand over time. We can set the marker size, that's the dots, what type we would want. This is there usually different values we can set for marker. The same case with color, just for whatever, you can use blue, you can use yellow, you can also use hex code. And also we set also the size, the figure size, that's the size of the plot. This 10 dimensions, just horizontal, 6 is just vertical. You can play around with those values as well. Right, we'll pause the video and then work on the challenge. Right, lastly, we can calculate the difference in time series data. So assuming that we had this data set that we are going to see here, and we wanted to maybe convert, assuming we wanted to convert, not even convert, calculate the time difference between maybe delivery date and order date, to just be able to know how many days it took for each and every record, to be, for each and every material to be delivered. Then we can, first of all, convert those two date columns to have a datetime format. After that, we can sort those values just for time series analysis, most cases, and then we would then after that calculate the time difference, which would be, we could still use the subtraction operator, where we get the delivery date minus order date, but at the same time we can also calculate time difference using some built-in functionalities, such as using the def function dt.days, which will give us the time difference in days, and we store that in a new data frame, a new column. And yeah, we display the final data frame. All right, so that's it with regards to that challenge. Pause the video and then work on the challenge itself. Okay, so that's it with regards to actually this Pandas challenge, day 23. We hope you're able to practice and get better and learn a few more things, maybe fill in a few gaps when it comes to those Pandas concepts that might have not been second nature. If you did find value in this resource or this video, be sure to give this video a thumbs up. It helps a lot, tells us that we're doing a good job, and we should look towards creating more of such resources. And if you'd want to be informed when we post such future learning experiences or challenges, be sure to subscribe, and see you in the next challenge. That's day 24. Bye-bye.